morning, everyone. Please put your camera on. If it will help me, as I told you several times. Okay, Erin has two questions. Go over number 13 and 8. Okay, we can do that. Okay, any other questions? Okay, so we go over those and then we proceed. So number 13 and number 8. Okay. All right. So the question here is number 8. Simplify the expressions for values of the variable for which it is defined. So we have the following. I'm going to simplify this. So they gave me tangent x, so that's number 8, times cosine x. And they want me to simplify it. Okay, so the goal of this problem is really to practice all our definitions. So let us remember, what's the tangent? Quickly.
Sine over cosine.
Sine over cosine. Okay, so now we're going to substitute the tangent by its value. So tangent of any angle, it's the sine of it divided by the cosine. And you multiply this by the cosine. Okay, that's really the idea. So what this will give me? Anybody?
Wouldn't it just leave you with sine?
This would only leave me with sine. Absolutely correct. That's what they mean by simplification. Okay, because eventually you will have to do the step of simplification yourself. So I replaced the tangent by sine over cosine times cosine. So basically we are simplifying the sine of and cosine. We can simplify them and that will leave me with sine. So, or another way you can look at it, just to make sure we get our fraction straight. This is the cosine. And this is basically, you multiply the numerator. It's sine times cosine. Now, cosine is a common factor in the numerator and denominator, so we can simplify it and gives me the sine. Okay. Now, number 13. I'm gonna look at that. Okay. One minus sine squared t over cosine t.
I meant number 13 on the 7.6.
Oh,
sorry.
That's okay. How about number 8? I didn't.
That was right. Number 8 was right.
Okay. So number 13 on 7.6. Yeah.
Yeah.
Okay, thank you. So let's go through that. And what's the question here? Okay. So we have the following function. H of theta is the tangent plus 2. Okay. And basically, they want you to do the following. Find the vertical asymptote. I did not define vertical asymptote, but now I will define in a minute for between 0 and 2 pi. All right. Okay, very good. So this is the tangent. And this new function is the tangent plus 2. It means you take the graph of tangent, you shift it up by 2. That's really what it means. Whatever tangent is, we're going to shift it up by 2. Let us recall how the graph of the tangent looks like. So, okay. Now I have to go back to you. When is tangent not defined? When does the tangent have issues? For which value of the angle? Which angle I can put here? The tangent does not give me a number. Anybody? 180, do you agree with him? What's tangent 180? Every time you give me a number, I'm going to check if you're right or not, okay? So what's the tangent of 180? Is it defined or not? Back to you. Tangent 180 is the sine of 180 over the cosine of 180, right? What's the sine of 180? It means this is my unit circle. Okay, that's my unit circle. 180 is up here. What's the sine of it? Quickly. Travis, what's the sine? 0. What's the cosine? Travis? -1. 0 over -1 is what? 0. There is no issue with that. So there is no issue with tangent 180. When is the tangent have problem? Which angle I will plug it here and there is no output. The tangent is not defined. We've talked about it last time. I will mention it one more time. What is the tangent? Okay, the tangent is, because this has to be clear in your mind, it's the sine over the cosine. So now the question is, which t can I input here, then I will have nonsense? Which value of t? Now Jaden is giving me the right answers. Which value of t? That when I plug it here, this would not be a number. Every t that makes cosine 0 give me a problem. Okay, pi over 2. Now we're thinking better. Every t that makes the cosine equal 0 will be problematic, because then the tangent will be something over 0 which is not defined. So now my question to you, I'm going to ask you a following questions, and I'm going to pick one student. The student has to answer me. Find the values of t. So give me a bunch of values of t where the cosine is equal to 0. Give me a value of t. I can see some on chat, but I want more. Give me the values of t where the cosine equal to 0. I will do that prior to going back to the problem that you guys asked. And the way you answer this question is, you can go to your unit circle and ask yourself, which angle give me the cosine equal 0? Or you can go to the graph of the cosine. So you can do it two ways. Either you can think on the unit circle, or you think on the graph. And the graph is cosine is this. That's the graph. Okay, I give you a minute, and then I'm going to pick one of you. And I want you to be clear on this. No question asked. Okay. All right, I will pick one and see what they came up with. As you remember, I picked the student arbitrarily. I don't remember the student I picked. Phoenix, do you have any input? Phoenix, are you with me? Okay, I move on. Samantha, are you with me?
Yeah.
Okay, can you answer the questions? The best of your knowledge.
The only ones I came up with was 90 and 270.
90 because it's here, right?
Yeah.
Because, okay, that's 70, so that's good. And what's in radian? What's 90 in radian?
I don't remember.
It's pi over 2.
Okay.
Okay, all right. The other angle is 270. What's 270 in radian? How many pi over 2? 1, 2, 3. Okay, those will give you. Now on the graph, how can you see them on the graph? It's right there. That's how you see them on the graph. So if you can either think here or think here. So you have two ways of thinking about this problem, or you can see it right there. That's the 3 pi over 2. Who can give me one more value? Aaron is giving me another one. So you have 3 pi over 2. You can keep rotating. Pi over 2, 3 pi over 2. Then you can go back here. That's going to give you the 5 pi over 2. And on the graph, that's the 5 pi over 2 right here. That's where the cosine is equal to 0. And then you can keep moving. You can add another pi, 7 pi over 2. So basically, I keep going around the circle and adding, going to all those angles that correspond to those two. And we can go backward, minus pi over 2. It means I start here and I go down by pi over 2. That's also will give me the cosine. So the tangent, find the values of t such that cosine t equal to 0. You can go to your graph, to the unit circle, or to the graph and pick them up. So this tells me that when t takes any of those values, the tangent doesn't have an output. So if I put pi over 2, I will have 1 over 0, which doesn't make sense. And the graph of tangent was like that. So this is pi over 2. This was minus pi over 2. And this is 3 pi over 2. And the graph was like this. Right here, there is no output. That's what we're going to call the asymptote. And then the graph went like this. So as t increased from 0 pi over 2, the value of tangent gets larger. That's really the graph. And then the idea is that the graph repeats itself every pi. So if this is, the graph repeats itself. That's the graph of tangent. Pi over 2, this is called the asymptote, and this is called the asymptote. Now, this one is the tangent lifted up by 2. So the graph is going to be exactly the same, but we're going to lift everything up by 2 units. That's what's going to happen. So this one's going to be like that. Lift it up by 2 units, come down. Lift it up by 2 units, and come down. But it's going to be exactly the same graph, but it's going to be shifted by 2 units. So also, this new graph, this function, if I plug in pi over 2, 3 pi over 2, minus 3 pi over, minus pi over 2, there will be no output for this function. And that will be my graph. So the asymptote, what they mean by asymptote, basically, it means those lines. Those lines are the asymptote. It means where the function is not really making sense. Let's look at your last questions. And I saw one, which is number 7 in section 7.6. Okay, let's look at number 7 in section 7.6. Okay, so the question is, find the tangent of minus 30. Okay, and they want to find the exact value. All right, always we go after the definition. The tangent is the sine of minus 30 over the cosine of minus 30. So finding the tangent, I need the sine and the cosine. All right, so what's the sine of minus 1/3? And I want the exact value. It means I don't want you really to pick up your calculator. I want you really to remember the value of those special angles. So let me help you out. We'll remember the following. Pi over 6, this is the 30 degrees. Pi over 4, that's the 45. And pi over 6, that's the 60 degrees. What's the sine? And what's the cosine? And there we go back here. Okay. What's the sine of 0? What's the sine of 0? Either chat or speak up.
0.
0. What's the cosine?
1.
1. Always your unit circle. What's sine pi over 6? Who remember that? what's the sign of it? So if you take pi over 6, and I'm asking you about the sign, what's the sign? That's a half. What's the cosine? Square root of 3 over 2. And then this is square root of 2, square root of 2, and this is you flip them. So these are the basic values. All right, now I want sine of minus 30 and cosine of minus 30. This is equal to what? What's the cosine of minus 30? If I go back to my unit circle, I need the cosine of minus 30. Minus 30 means you start from here and you go down by 30 degrees. Okay, that's what we got. All right, so what is the sine of minus 30? Using this table, who can give me the sine of minus 30? And explain. So that's minus 30 degrees. What's the sine of minus 30? Minus a half. We just take the angle, we just go back. We draw the reference angle, whose angle is 30. And then this is a half, so this should be minus a half. So the sine of minus 30 is minus a half. What's the cosine of minus 30? Again, I want you to think. So I'm going to draw another circle for the cosine. Remember, the cosine is the x coordinate. So we draw our angle, minus 30. And we're going to use this table to figure out the cosine of this. Square root of 3 over 2, absolutely correct. So I take this point. This here is the square root of 3 over 2 and a half. So this point down here will be square root of 3 over 2 and minus a half. So cosine minus 30 is the square root of 3 over 2. Now the algebra. How do we divide fraction? It's the numerator times 2 over the square root of 3. Which gonna give me minus 2 over 2 square root of 3, which is minus 1 over the square root of 3. Okay, so that's how we expect to find the exact value. So for the exact value, you have to put this in front of you. Once you put that, then sine over cosine, and you start figuring out what's the sine of minus 30. That's something we've done before. I know the sine of 30. The sine of minus 30 is this y coordinate. By symmetry, this is square root of 3 over 2 a half. This is going to be square root of 3 over 2 minus a half. So that's the sine of it, the minus a half. And right here, I can pick up this. Okay. Any other questions? All right. So let me ask you, we introduced last time the tangent, and we introduced a lot of other functions. So I will ask arbitrarily to you, what's the definition of cotangent? I'm going to pick one of you and ask. Nathan. Because I asked you to actually, you have to memorize the definition. Nathan, do you have any memory? Okay. I move. Maddie?
Hey there. The
I know.
cotangent is cosine of t, if that's what, or p, whatever we're using,
Yeah.
over sine, and it can also be 1 over tangent.
Absolutely correct. It's the cosine over the sine or 1 over tangent. Okay, what's the secant? You have to memorize those. Kishan, do you have anybody? What's the secant?
1 over cosine.
1 over cosine. And finally, what is the cosecant?
1 over sine.
1 over sine. Crucial to memorize those. I know that you guys have the notes in front of you, but you have to memorize them. It's absolutely crucial for you. Very good. So what we're going to do today is the following. suppose I tell you, today we're going to move on to section 7.98, I guess. Yeah, section 7.8. Called the inverse trigonometric function. Okay, and this is the idea. Suppose I ask you the following question, okay? Give me example, give me an angle theta or t, find an angle t, such that the cosine of t equal 1/2. Give me an angle whose cosine is 1/2. Is this an easy or a hard question? Who can give me an angle whose cosine is 1/2? And I'm going to put this in front of you. Who can give me an angle whose cosine is 1/2? When I evaluate the cosine, I get 1/2. Quickly. I put this in front of you again on purpose. 1/2. Okay, that's an angle. 60 degrees or pi over 6, that's an angle. When I compute its cosine, you get 1/2. Okay, so today what we're going to do is we're gonna move backward. In other words, I'm gonna give you the cosine, and the question is how to find the angle. We're gonna start moving backward. So if I give you an easy one, like cosine equal 1/2, okay, you have no problem, tells me, okay, 60 degrees. Okay, that's an easy problem. Now, who can give me another one besides 60? So that's the angle that you guys gave me, 60 degrees. Who can give me another one besides 60? 120? No, I want the cosine to be 1/2. That's the cosine. Right, we have to go down here. This one. Another one would be 300. That's the 60. Since the cosine is the x coordinate, I need another one that have the same x coordinate. It's going to be 300. And there are other angles. The minute you add 360 to that, you have the same. So if I tell you find an angle such that cosine t is 1/2, because we know those particular angle, you can give me 60, you can give me 300, you can give me a lot. But now the question is, suppose I ask, find an angle t such that the cosine of t is nothing special, like 0.4, for example. How can I find an angle? So now the question is going to become how to find an angle. That's the cosine. That's 0.4 right here. And the question is how to find this. That's really my question. Okay. Now, this is a hard problem, of course, but on our calculator, we have a function that will give me the angle whose cosine is 0.4. So we're moving really backward now. I'm giving you the angle, the cosine, I want the angle. So on our calculator, and then we're gonna figure it out. Calculator, simple as that, because those are hard questions. There is a button or there is a function that gives the angle. But what's called the function that gives the angle? And here I'm going to leave an empty spot whose cosine is 0.4. And the line whose cosine is 0.4. So on our calculator, there's going to be a function that gives the angle. But what's this function called? This function is denoted by cosine. You're going to hit the notation unless you know it. Inverse of 0.4. So there is a function called cosine inverse. So this is, we call it cosine inverse. Or both would mean the same, or sometimes it's called arc cosine 0.4. So there is a function called cosine inverse or arc cosine, which will give me this angle, which gives the angle. the angle. So in other words, I'm going to pick up my calculator right here. And my calculator is going to be put in, my calculator right now, I'm putting it in degree mode to make the problem a bit easier. And there is, I would like you all to pick it up, your own calculator, and there is a button called cosine inverse. I'm going to hit it, cosine inverse, cosine inverse. And I'm going to hit 0.4, enter. I get 66.42. Exactly, it means this function, this new function, will give me the angle whose cosine is 0.4. So cosine inverse here, by picking our calculator, cosine inverse of 0.4 is what we picked up, 66.42 degrees. It means the cosine of 66 is 0.4. Okay. So now the question is, why did I keep this blank spot here? Why did I keep this blank spot here? For the following reason. Is that how many angles have cosine 0.4? So if this is the picture here, cosine 0.4, I'm looking for the angle. Is there one angle or a lot of angles who have for cosine 0.4? How many angles have the cosine 0.4? Is it only one, or there are two of them, or three of them? What do you think? At least two. At least two, because when I add 360, I can generate more and more. The calculator does not give you all of them, because the calculator is going to give you one of them. And the calculator is going to give you the one between 0 and pi. So the calculator, there is a that gives the angle between 0 and 180. It gives you one of it, or between 0 and pi, if I'm thinking in radian. So it's going to give you one angle whose cosine is 0.4. Okay, so that's really our main function today. So let me define it in a more rigorous way. So what's the cosine inverse? Let's see what's the cosine inverse. Okay, so in general, cosine inverse of x is the angle between 0 and pi, I'm using radian, whose cosine is x. So that's what's the cosine inverse. So cosine inverse is the angle. So it gives me the angle between 0 and pi whose cosine in x. So cosine inverse of x, or both notation are used, or cosine, arc cosine, this or this mean the same thing, equal to theta means. What does it mean, cosine inverse equal to theta? It means that the cosine of theta is x, and theta is between 0 and pi. So that's a whole new function called cosine inverse, extremely useful. Its goal is, if I give you the value of the cosine, it gives me the angle. So you know the cosine, it gives me the angle. So let us practice this a little bit. Okay, so I'm going to ask you the following. Without a calculator, I cannot control you, but without a calculator, find cosine inverse of 0. What am I talking about? What am I talking about? What does this mean? Find cosine inverse of 0. It means find the angle theta. That's what it means. Find theta, the angle, such that the cosine is equal to 0. Okay, that's really what it means, find cosine inverse. It means find the angle whose cosine is 0. So now back to you. What's the cosine inverse of 0? Okay, Rebecca is telling me 90. Is she right? That's in degrees. If I'm asking you the question in radian, it is pi over 2. So I'm going to answer every question in both degree and radian, so you start being confident. Now, your classmate is telling me cosine inverse of 0 could be 70. What's the problem with that answer? Okay, I don't want you to write this. I need to write, but you don't have to. So if cosine inverse of 0 equal to 70, what is the issue with that? Anybody can tell me what's the issue with that answer? The cosine inverse gives you which angle? It gives you only one, the one between 0 and pi. It means when you plug in cosine inverse in your calculator, it's not going to give you 90 and 270 and 270 plus 360. It's impossible. It's going to give you one of them. The one that it will give you is the one between 0 and pi. So cosine inverse of 0 is one angle. Which one is the one between 0 and pi that satisfies cosine theta equals 0? So that is not acceptable. The cosine of this angle is 0, but the cosine inverse gives you the one between 0 and pi. That's what the definition of cosine inverse is about. All right, so otherwise, it's impossible. It will not be a function, it will not be a rule. Okay, now I move on to the another one. Again, what's the cosine inverse of 1? No calculator. It means, what's the angle between 0 and pi such that the cosine is equal to 1? That's what it means, cosine inverse of 1. It's the angle between 0 and pi that satisfies this condition. So what's kind of cosine inverse of 1? Absolutely 0. Whether it's radian or degree, it's just 0. Okay. Now two more. What's cosine inverse of the square root of 2 over 2? It means, what's the angle? So I keep repeating till it becomes, find theta between 0 and pi such that cosine theta is the square root of 2 over 2. That's really what it means. So it's 45 degrees if you're moving in degrees, or it's pi over 4 if I am working in radian. So that's really what the cosine inverse is. Right. My last question is, so we're not using the calculator. My goal now is only to understand the notation. And then we're going to start using the calculator. Now I'm going to give you the following. Don't use your calculator. I want to ask you the following. Cosine inverse of 2. Means find the angle theta such that cosine theta is equal to 2. What will be your answer? I'll give you a minute to think about it. I want you to think about it. Think about it hard. Doesn't work. We're getting better. One of your students is telling me that it doesn't work. Rebecca, why it does not work? So cosine inverse of 2, one of your classmates, she put it privately to me, and her answer was it doesn't work. There is no way you can find theta, an angle whose cosine is equal to 2. Why? She is absolutely correct. Who can pick up on her answer? And my answer is why. My question is why it's not defined. Why there is no way you can find an angle whose cosine is 2. Who would like to make sense out of that? What's the largest value the cosine can take?
1.
What? 1. What's the smallest value the cosine can take? -1. Can the cosine take the value 2? Absolutely not. That's really the reason. Is that clear? So why? Because remember the cosine, we started with the unit circle. That's the unit circle. The cosine was the x coordinate. So on the unit circle, the largest value the cosine can take is 1. The smallest is -1. Or if you remember the graph of the cosine, 1, -1. So cosine inverse not defined because the maximum value of cosine is 1. It's 1. So there is no theta, no value, no angle. There is no angle value of theta whose cosine is equal to 2. That doesn't work. Okay. So the only thing I can put inside the cosine inverse has to be a number between -1 and 1. So this tells me that cosine inverse of x makes sense when x is between -1 and 1. So cosine inverse of 2 doesn't make sense. Cosine inverse of 1.5 doesn't make sense because I cannot find an angle whose cosine is a number larger than. Now, we use the cosine inverse. We're going to use it a lot, especially starting next hour, is basically to solve problems, something like this. So I'm going to ask you the following question now. Okay, problem. Find t such that, find all values of t between 0 and 2 pi. So I'm going now to switch to radian such that cosine t equal 0.6. Okay, so the question is, I want to find all angles between 0 and 2 pi whose cosine is 0.6. So now basically now, this is my picture. That's my picture. 0.6, I want the cosine. So this is 0.6. I'm giving you the cosine and I want the angle. Okay, so how can I find the angle? Right. What's the first value? If I know the cosine, the function we've talked about today will give you one angle. Cosine inverse of 0.6. That's really what this new function is. Now, if I am in radian, I'm going to pick up my calculator and put it in radian mode because I'm asking you between 0 and 2 pi. So I'll put it in radian mode and then, mode, radian. And then I want the cosine inverse of 0.6. So cosine inverse of 0.6 means 0.927. 0.927. And now the unit is radian. Okay, it means that this angle here is 0.927 radian. All right, so I have the cosine, I want the angle. That's what this function will give me. Now, can anyone give me another angle? Because I want those between 0 and 2 pi. Who can give me another angle whose cosine is 0.6? So that's, if I take 0.92 radian, now let's see what 0.92 radian is. 1 radian is almost 57 degrees. So this should be almost 50 degrees. Who can give me another angle who have for cosine 0.6 using the unit circle? minus 53. Give it to me in radian because I'm working in radian. So basically, this one, basically I want that angle. So minus 0.6, not 0.6, no way. It's 0.927. What's this angle here? Minus 0.92, that's one good answer. If I want it between 0 and 2 pi, who can give me the answer between 0 and 2 pi? So if I want it between 0 and 2 pi, it means I want this angle. How can I get that angle? If this is 0.927, how can I get this angle from here to here? No, no, no. You guys know how to do that. I give you a minute and I want an answer. I want you to think about it. This is 0.92. If I want all the way to here, how can I get it? $5.36, how did you get that? I want the math. You take 2 pi, 360, and you take away 0.927. Okay, because from here to here, all around, that's 360 or 2 pi, because I'm working with 2 pi, minus that. And now you just plug in that number into your calculator and you proceed. So I will have 2 pi minus 0.297, I will get 5.35 radian. Okay, so now, we, as I said, we're moving backward all the time. All right. So question number 2, I will do another one along the same line. Find the value of t such that the cosine of t is equal, let us say, minus 0.4. Okay. All right, you have a minute to do that. What is your t? And I want t, okay, any t. Okay, find an angle t such that the cosine equal minus 0.4 and find the angle in radian. So I'm giving you the cosine. You have to find the angle. How can I find the angle? What's t? Anybody? You guys have your calculator with you? Okay, I want you all of you to pick it up. I want the cosine of t to be minus 0.4. I want t, and I want the answer straight from your calculator. How do you do it? That's my picture here. The angle is minus 0.4. That's minus 0.4. And I want the angle. So the angle is going to be the cosine inverse. That's what this function gives me of minus 0.4. And now I just have to plug in that into my calculator. And then I trust the student 1.98, and that's in radian. Otherwise, I will put the degree. It means this angle from here to here is 1.98. I'm giving you the cosine, you're giving me the angle. Now, the idea is whatever we did for cosine, we can do it for the sine, and we can do it for the tangent. So If I know the sine, the question is, can I find the angle? And if I know the cosine, the tangent, can I find the angle? So part 2 is basically I will repeat the same thing, but for the sine and the cosine. So the second function we're going to define is the sine. Okay, so what's the sine inverse? So let x be a number. Then sine inverse of x, or arc sine of x, is the angle. Now the sine inverse is going to give me the following angle, is the angle between minus pi over 2 and pi over 2, whose sine is x. Because the sine inverse is going to give me, if I give you the sine inverse is going to give me the angle. So in other words, sine inverse of x equal to theta means, the sine inverse is the angle. It means the sine of theta is x, and the sine inverse doesn't give me all the angles whose sine is x. It gives me the one between minus pi over 2 and pi over 2. It means minus 90 and 90. These are the angles that it will give me. Okay. So let us say I give you the following. I tell you that I'm going to pick up my calculator and give you the following. So suppose I tell you sine inverse of 1, for example, sorry, not 1, my apology. Suppose I tell you sine inverse of 0.4, for example. I'm just going to make up something. Sine inverse of 0.4, I'm just plugging things into my calculator, is 0.411. What am I talking about? What does this mean to you? What does sine inverse of 0.4 equal 0.411 mean? Okay. I'm going to start giving point for every student to answer. It's in radian, yes. What does it mean? What do you understand by that? Yeah, it's in radian. When I do not put a unit, it means it's radian. When the book doesn't put a unit, it means it's radian. When it's in degree, the unit is put. So what do you understand by this? What does this stuff tells you? So what does sine inverse 0.4 equal 0.411? What does it mean? What do you understand by that? What information I'm giving you? Is I'm giving you the following information. Telling you that the sine of the angle is equal 0.4. That's really what this means. Sine inverse of 0.4 is 0.411. It means the sine of 0.411 is equal to 0.4. That's what we understand by this function sine inverse. So let me do the same problem like I did before. I'm going to give you the sine. I'm going to ask you to find the following. Find without a calculator. What's the sine inverse of 0? It means you're after the angle theta, whose sine is 0. Okay. What's the answer? What's the sine inverse of 0? What's the angle whose sine is 0? That's equal to 0, because sine 0 is 0. What's the sine inverse of -1? It means, what's the angle? Such that the sine is -1. Which angle have sine -1? 3 pi over 2, not defined. Okay, I want more answers. 3 pi over 2. Who can give me another answer? Let me take you back. The sine inverse will give me the angle between minus pi over 2 and pi over 2. It does not give me all the angle. It gives me the one between minus pi over 2 and pi over 2. So the sine inverse of -1 is going to be the angle. So sine inverse of -1, it means gives the angle between minus pi over 2 and pi over 2. It doesn't give me all of them. It gives me this one. So with this in mind, the sine inverse of -1 is going to be minus 90, or in radian, minus pi over 2. So 3 pi over 2, the sine of 3 pi over 2 is -1. But the sine inverse, it means if you take your calculator here and you evaluate the sine inverse, you evaluate on your calculator will not give you, it gives you minus 1.57. It gives you minus pi over 2. It will not give you the 3 pi over 2. It gives you one of them, the one between minus pi over 2 and pi over 2. That's what our calculator will give us. Because it cannot gonna give me infinitely many. It picks one and gives me that particular one. Now, the same way we did with the sine before, we're gonna use those new function to solve problems. So suppose I ask you find the following. Find the values of t, all t between 0 and 2 pi, such that the sine of t is equal, let us say, 0.4. So I want you to find all values of t from 0 to 2 pi, where the sine is 0.4. So I'm giving you the sine. I want you to find the angle. Okay, so I'm going to give you 2 minutes to do that. And start putting your answers on Brightspace, on chat to see if you're getting it. I want the angle. I want all the angle from 0 to 2 pi. When you find their sine, you get 0.4. Give me this angle. Draw the picture and proceed. And give me the angle in radian. I want the answer from a lot of you. Not only one, not the same student. Okay. So we have to draw the circle. And the sine is 0.4. The sine is the y coordinate. And now what I want is the angle. That's what I want. And I want all the angle from 0 to 2 pi. So one of them is the sine inverse of 0.4. Now if I plug in, which is 0.411. And now the unit is in radian. That's the unit in radian. Now who can give me another value? I want 2 of them. So the calculator will give me this. Do we know how to find the other one? We've done this at the beginning of the semester, and you guys did it well on your exam. The other one is going to be this one. That's the other angle. How can I compute this other angle? Look at the picture. How can I get that? If this is 0.44, that's basically, you can think of it as the reference angle. It means this piece right here, this is also 0.411. So what's the angle in red? Who can give it to me? No, I don't want you to memorize. I want you to look at the picture. Look at the picture. All of you, look at the picture. What's the other one? And you have to tell me not the answer, how you got the answer. Because giving, right, the other answer is 180, which is a pi. You take away the 0.411. So it's going to be pi, just look at the picture, minus 0.411. Now, it's just a matter of evaluating, and I think one of your classmates gave me 2.73. So now if I know the angle, the sine inverse is going to give me, I know the sine inverse is giving me the angle. It gives me one of them. It doesn't give me all of them. It gives me the one between minus pi over 2, pi over 2. It's my job to find the other one by understanding, by using the symmetry of the unit circle. Okay, I'll give you another one, verbatim the same, and then I will move on. And I promise if you guys answer well. So question number 2 is the following. Find all values of t between 0 and 2 pi such that sine of t, I'm going to give the same problem so you guys will feel absolutely very comfortable with it. I give you 2 minutes and I want answers from a lot of you. While I do it. But you realize I always draw. I am like to understand what I'm doing. So 0.6 should be right there. That's my unit circle. I'm after the angle. And I want all the ones between 0 and 2 pi. But there are 2 angles. All right. Okay, I need more. I'm still having the answers from the same student. I want all the student. I want answer from other student. Okay, I'm having different ones. So let's move on. Any more? Okay. All right, keep going. I'm still having different stuff. I want more answers. Okay. The first one is if the sine of t is 0.6, it's the sine inverse. That's what the sine inverse does for me. Sine inverse of 0.6. So now I am in radian. So sine inverse 0.6, according to my calculator, is 0.6435. So let's pick up the first 3. So 0.643, that will do in radian, which is a little bit like 40 degrees. But I'm thinking radian now. How do I get? So that's this one. That's the one that the calculator gives. So the calculator gives this. Gives 0.643. That's the one your calculator is giving to. It's your job to give me, that's fine. Your job to give me the other one. What's the other one? It means this one. How can I get this one? We get it by using the symmetry. If this is 0.64, this is right here. That's my reference angle is 0.64. So I always really look for this little angle here. That's my reference angle, which is right there. And then this will give me is the pi minus the 0.643. Okay. All right. Now I'm going to give you again another problem along the same line, but a little bit not much harder. So the question is, find all values of t between 0 and 2 pi. So I want those such that the sine of t equal, let us say, -1/3 or -0.33, but I want to keep it in fraction form. So I want, right? Again, I we draw the unit circle. And if I want the sine to be -1/3, the sine is the y coordinate. If this is a 1, so this should be right there. That's the -1/3. And then I want the angle whose sine is -1/3. So I know that there is this one and there is this one. All right. I give you a little bit to think about that, and then we move on. I'm giving you the sine. You have to give me the angle. Remember, the calculator gives me the angle. It gives me one of them. And then we start finding the other ones. Please, each one of you feel responsible for doing them. That's how you're going to learn it. First, tell me what your calculator is giving you. Okay. Sine inverse of -1/3. It means -0.339. Did anybody get anything like that? Did anybody get that? So in my picture, where is the -0.339? Now, let me give you an idea. This is in radian. That's now one radian, just to help you out with radian and degrees, is 57, almost 57 degrees. So 0.3 is going to be almost 20 degrees, but I'm going to stay with that. So in the picture, it means this one here going down, this is -0.339. That's the one your calculator gives you. Now, if I want them between 0 and 2 pi, who can give them to me between 0 and 2 pi? So this is one answer. So if we want between 0 and 2 pi, what are the angle between 0 and 2 pi? Okay. So if this is -0 point, this one. Now this mean here, that's what we call the reference angle. This is 0 point, sorry. This is 0.339. So the red angle is what? What's the red? I don't like answers without explanation. The red one is what? How can you get the red one? Jaden, do you have any idea how to get the red one?
Would we do 3 pi divided by 2 minus -0.339? Or would it be pi?
Just look at the picture. It's pi plus.
0.339.
Am I right?
Yes.
Understand? I don't really guess. I really look at the picture. From here to here, I have a pi. I go after the reference, the little angle here. That's the pi up to here. And then I'm adding 0.399. I get the red one. Then this is equal to, I really don't know. Now I just pick up my calculator and I evaluate that. Plus 0.339. And I'm getting 3.48, which is what your classmate gave me, but I want her to explain. Who can give me the other one? The other one would be, I wish I had a green color. I don't. The other one would be from here to here. What's going to be from here to here? Jaden, can you figure it out looking at the picture, basically? How do you compute this angle? Going all around till you hit that. One is minus 0.339. I want it to be the positive one. What's going to be?
So if pi plus 3. So
Look at the picture.
Okay. 2 pi
2 pi.
339.
What do you want me to put here?
Plus wait, minus
Minus.
0.339.
Here you are. Okay, and now I just have to evaluate this. 2 pi minus 0.339. It means 5.944. So there are a lot of angles whose sine is minus a third. Your calculator gives you one of them, minus 0.339. That's one answer. But let us say I'm asking Q, I want those between 0 and 2 pi. And then, okay, the calculator gives you that, and then you use the picture. So this will, the reference angle here is 0.339, and then you use it to figure out what are the other angle and the symmetry of the unit circle. So this will give me this little angle here is 0.339. So I have the pi plus that, and then I take, okay, it's 2 pi minus this, end of the problem. So use the picture, do not memorize at all. Use the picture you have. All right. So now we defined two functions. The sine inverse, those are absolutely crucial functions also, because those are functions that if you know the angle, you know the sine is giving to the angle. You really want the angle. The last time is that tangent, as I said last time, is a very important function as well. So the last one is going to be the tangent inverse. It means if I know the tangent, what is the angle? And tangent is, as you will see later on, is important. So we're going to define a new function called the tangent. Tangent. So tangent inverse of x, or arc tangent x is the angle. Is the angle between. Now the difficulties in those is you have to remember each function gives you which angle. It's the angle between minus pi over 2 and pi over 2 whose tangent is x. So when you read tangent inverse of x equal theta, it means theta is an angle whose tangent is x, and which angle is the one between minus pi over 2 and pi over 2. So that's the one your calculator gives you. It gives you the one between minus pi over 2 and pi over 2. So the cosine inverse, your calculator will give you the angle between 0 and pi. The sine inverse and the tangent inverse, your calculator will give you the one between minus pi over 2 and pi over 2. I know it's hard to keep track with them, but we should know which one your calculator gives you. So before we take a problem along those lines, my question to you is the following. What is tangent inverse of 0? It means find the angle whose tangent is 0. Does anyone know the angle whose tangent is 0? Anybody? Just remember, what's tangent? So I'm looking for an angle such that the sine over the cosine is equal to 0. So which angle will give me that? Which angle such that the sine over the cosine is 0? because that's what the tangent is, sine over cosine. Which angle will give me that equal to 0? 0. Because if I plug in 0 for theta, sine 0 over cosine 0, cosine 0 is 1, sine 0 is 0, that's equal to 0. Okay. Now, what's tangent inverse of 1? Or, I know it's so much notation, but I have to talk about that. Or arc tangent 1. They mean the exact same thing. And believe me, when I was a student ages ago, that's the one I've learned. More than that, because this tells me the angle whose tangent is 1. Now, who remember that? Exactly, that's 45 degrees or pi over 4. Why it is the case? Because what's the tangent of pi over 4? So there is a reason for those. It's the sine of pi over 4 over the cosine. But we know that the sine and the cosine of pi over 4, they are equal. So that's both of them is the square root of 2 over 2, which is equal to 1. Okay, so tangent inverse of 1 or the arc tangent of 1 is equal to 45 because of that. Now, the same way we solved problem involving tangent, sine and cosine, we're gonna solve problem involve the tangent. So suppose I give you the following problem. Find the angle, and this time I'm gonna restrict my scenario. Find the angle in the first quadrant. So I'm gonna make it simple for us now, such that, okay, if I want the angle between the first quadrant such that 2 tangent theta equal to 1. Okay, I made it a little bit easy and a little bit hard at the same time. So I want an angle such that 2 times the tangent equal to 1. Right, how can I solve this problem? Right, the way we're going to do it is, okay, first, I'm going to isolate my tangent. It means if this is the case, it means I want the tangent to be equal to half. So isolate the tangent. And now I know theta. And this time I'm asking for the angle, one angle between the first quadrant that satisfies tangent theta equal to half. So it means I know the tangent. I'm after that. This means that theta equal, I'm not asking about a lot of them. I'm asking about one of them. Tangent inverse of 1/2. Okay, you guys are working. It means 0 point. I'm copying your classmate. And because when I do not put unit, that's radian. When I do put unit, and that's degree. So theta is 0.464. Okay, so tangent inverse is this powerful function that I'm giving you the angle, you're giving me, I'm giving you the value of the tangent, you're giving me the angle. Okay, so let's do another one along the same line, and then we stop. So question is, find theta, again in the first quadrant, such that 3 tangent theta minus 7 equal to 0. Okay, I give you a second to solve this problem. And the starting point should be to isolate the tangent first. Isolate the tangent first, all right? And I expect answers from you. Okay. Yeah. Anybody else? Please, I want answers on the chat to see what are you guys are doing. So I'm having one answer so far. I want more than that. Since time is up, I will help you with it. So 3 tangent theta, okay, it means that with the isolate tangent, it means 3 tangent theta equal to 7. Tangent theta is 7/3. Now, no, we divide. Be very careful with the algebra. 3 times tangent theta equals 7. And then we have to divide by 3 to isolate the tangent. We divide by 3 to isolate the tangent because 3 is multiplied by tangent, then we have to divide to isolate it. And then this would give me the theta is arc tangent 7/3. And some students are giving me 1.165, and I think that's the correct 0.667, and that's the correct answer. And this is radian. It's 1.6 radian because that is, we're putting our calculator in radian. All right. For next time, I'm gonna give you problem from the book, and I'm gonna give you some problems like the one we did here. And you will have your quiz on Monday, so make sure you study the material very well. Okay, so your quiz will cover 7.7, 7.8, and 7.9. All right, class is dismissed.